Hi guys, welcome to my channel. This is me, Kashish. Hope you all are doing great. I am the student of Computer Systems Engineering 5th semester at Sakhar IB University. As I told about to share the information on Cisco Packet Tracer, so today I will go to share how I structured this small office using Cisco Packet Tracer, and this all is motivated and assigned by my supervisor, Sir Irfan Yunis. So come and see how I structured it. Yes guys, before wasting our time, let's get start now. As I told, my project is about setting a small office. I already introduced. My name is Kashisthani. I am student of Computer Systems Engineering at Sakhar IB University, and this project was assigned by Sir Irfan. So here is the description of the project. Step 1. Understand the requirement. There are three locations: location 1, location 2, and location 3. At location 1, there is marketing team, IT team, and finance team. Location 2, marketing team, IT team, and finance team. Location 3, audit team, management team, and security engineer. Another one is DHCP. One location should get the IP address dynamically via DHCP. Another location should use a DHCP relay agent to get IP processes from a central DHCP server. Team communication: team leaders should be able to ping each other but not their own team members. Team members can ping each other within the same team but not across locations. Audit team and management team should be able to ping each other and team leaders across locations. The security engineer should be able to ping team leaders and audit team at location 3. A special committee consisting of two members should be able to ping each other, the security engineer and the audit and the management teams. Network segmentation: each location is on a different network like separate subnets. Step 2. Initial setup in Packet Tracer. Add devices. In Cisco Packet Tracer, add routers, switches, and PCs as needed. Ensure you have at least 3 routers, one for each location, and enough switches to connect devices. 10 PCs for each team per location, 2 special committee members, 1 security engineer. Each router should be connected to the respective switches at each location. Assign IP addressing. For location 1 and location 2, assign different subnets. Location 1, assigning this IP address and finance team, and at location 2, assigning this IP address, and location 3, assigning this IP address for audit, management, security engineer, and a special committee. Subnets mask. Location 1, location 2, location 3, these are the ranges. And step 3, configuring DHCP. Configure DHCP for location 1, and on the router at location 1, configure DHCP to assign IP address dynamically to PC. Example, create the DHCP pool. Here the components: Arduino, IP DHCP pool, location 1 pool, network is that, and default router is that, DNS server is that. Configure DHCP relay for location 2. On the router at location 2, configure a DHCP relay to forward DHCP request to the central DHCP server located in location 1. Command: CSS IP helper address. This will allow PCs and location to receive their IP addresses from the DHCP server in location 1. There is a step 4, VLAN and inter-VLAN routing configuration. Create VLANs for different teams. On the switches in location 1 and location 2, create VLANs for each team, marketing and finance, assigning PC to the respective VLANs based on the team they belong to. Router configuration for inter-VLAN routing. Enable router on a stick configuration to allow communication between VLANs in each location. Its example is Kotlin interface, which is connected to interface giga 0/1.10. Encapsulation, IP address, and step 5 is security configuration. Now let's apply the specific rules on communication between teams and location using access control list, SCLS. After their team leader communication, apply an SCL to permit team leaders to ping each other across locations and any team members from pinging team leaders. Team member communication: allow team members to ping other members within the same team at the same location but block communication between team across location. Security engineer communication: the security engineer can ping team leaders and the audit management teams at the location 3 but can't ping the team members at location 1 and 2. Special committee communication: allow the special committee to ping each other and other security engineers as well as audit and management teams. Step 6, testing and verification. First one is ping test. Test the communication between team and leaders, team members, and special committee. Ensure that the ping restriction: team members can't ping leaders, and communication between locations is properly blocked or correctly applied. Second one is troubleshooting. Check router interfaces for correct IP configurations. Verify VLANs, assignments, and SCL rules if there are issues. So here the summary of these all steps: add and connect devices, Assign IP addresses and subnet masks to each location, configure DHCP at location 1 and location 2, and configure VLANs and router on a stick for enter VLAN routing. Apply CS to control access between teams, team leaders, a special committee, and the security engineer. Test the communication rules and troubleshoot as needed. This configuration provides you a segment network with controlled communication between teams at different locations based on the specific rules. So now going on the working of the project. So guys, here is the working of the project. This all is my project on Cisco Packet Tracer working. Step 1. Devices in each department connect. Each department like marketing and finance computers connected to a local switch. The switch allows all the computers within the department to communicate with each other. Step 2. IP address assignment. The DHCP server automatically assigns unique IP addresses to each computer to ensure they can communicate on the network. Step 3. Inter-department communication. If one department needs to send data to another, the data passes through switches to a router which forwards the data to the correct department switch. And step 4, Internet or Central Server Access. For Internet or Central Server Access, request go to DNS server. After that, the web server handles the internal apps or hosted websites. Data flows through the router and is directly to the appropriate server. After that, fifth one is security monitoring. The security engineer members all activity to detect and prevent or security threats. The sixth step is special committee or isolated groups. Smaller groups like the special committee operate informationally for but remain connected to the network for secure collaboration. Summary: Internet data flow, inter-department, server access, and security. Now let's come to see how my project works. This all is about my project. I can show the PC is connected to PC1 like this. I am sending packet. You can see it is successful. Like PC1 and PC this are connected. And also I can show this PC is connected to the router. You can see this also came successful means the PC is connected to the router. After that I can show by command line if there is PC8. So let me show you the IP configuration of PC3. There is IP configuration of PC3 is 192.168.1.3. So in PC8 I am going to show you by command line. There I am writing ping 192.168.1.3. You can see the PC3 is connected with the PC8. This all was how my project works, and now come to its report. So the report of my project is that this is about a network setup designed for communication and reliability. Let me explain it in a simple terms, but first one it ping test. Sorry. First one is ping test. A ping test is due to check if a system is connected to a network. If the system does not respond within a certain time, it is considered or disconnected. Teams and VLAN setup. There are two locations, each having three teams: marketing, IT, and finance. Each team is in its own VLAN, virtual local area network, which keeps them separate. However, the team leaders, all these teams are in the same VLAN. They can directly communicate with each other using ping. Third one, router R1. Router R1 connects the first two locations and uses the RIP routing information protocol to route data between them. It also acts as a DHCP server for location 2, meaning it assigns IP address automatically to all pieces in location 2. Router 2. Router 1 is connected to router 2, which acts as a DHCP CP relay agent. This means it forwards IP requests to the DHCP server. R2 uses both RIP and static routing to send data to the right network. One of R2 interfaces is connected to this IP where the security engineer is located. Another interface connected to a network with a special committee that has only two members. Fifth, audit management and team leaders. The audit team, management team, and the team leaders from the first two locations share the same VLAN, allowing them to communicate with each other using ping.
6. Accessing a website. If you access the website this from any PC in location 2, it works because the network is properly set up. Even if the DNS server responsible for translating the website name into IP address is disconnected, you can still access the website because the content is saved in the PC's cache temporary memory. So that's it. Thank you.
It's really appreciating and thankful that guys you gave whole attention on my project, and so also stay tuned also for other activities. So I need your love, support, and please don't forget to subscribe my channel. Thank you.